Hello, good evening, everyone. Hello, can you guys hear me? Hello, Ankit. Hi, Prashant. Hello, Panimyam. Hello, Anil. Hello, Pradeep, Yashwant, Pavan, Murli. Welcome aboard. Yes, are you guys good to launch? Can you guys see me? Can you guys hear me loud and clear? Hello, Pushpanjali. Welcome aboard. So, today we are going to discuss the board paper which was launched officially by CBSE. So this is a sample paper. It's a good collection of 55 questions, and this will give a fair idea of how the actual paper is going to come in a month. So all those CBSE students preparing for the term 1 examination, today's session, the mock test discussion is for you with your favorite captain, Shreyas. Hi Tarun, I'm very good. Thank you Raghunesh for enrolling into my electrostatics and current electricity problem solving course. Glad you did it, and I'm really eager to meet all of you this Monday. By the way, let me tell you, I'm going to share a personal Telegram channel link, where I'm going to post all the assignments, all the updates, and all other important problems, etc., whatever you need for preparation of JEE as well as CBSE. So if you're a JEE aspiring student, so you should join the channel, and the channel link will be shared only in the course which I have launched, and it is starting this Monday in the pro subscription, and it is free of cost. To join pro subscription, you need to check out the link which is there in the description box below. Not only will you get my course, but also Shimon Sir's, Wasim Sir's courses and all the other teacher courses free of cost once you're in the pro subscription. So I think the pro subscription plans are as low as 3,000 rupees per month when you use the coupon code SHHPRO. Just check it out. And if you want to know more about me, definitely you can go ahead, check out all my pictures and videos on my Instagram handle. So one thing that I would like to tell about Vedantu, a lot of people think Vedantu only produces results in JEE or NEET. Well, we have been producing results not just in these competitive examinations, but also Olympiads, even in board examinations like ICSE, CBSE, including CETs. I mean, look at this, so many toppers who have scored about 98% in boards, all from Vedantu. Look at their percentages, 100, 99.8, that's crazy. So these are Kerala board toppers, ICSE board topper, Karnataka board topper, JNK board topper, CBSE board, everywhere. And all the students who are studying in Vedantu are performing better in their CBSE boards as compared to the students who are not studying in Vedantu. That's what our data says, and that's really crazy. I really hope that you guys too gear up for your preparation in our CBSE exclusive classes. So when you join JEE course, you also get preparation for CBSE. Many coaching institutes do not do that, but we are going to give you assignments, solutions, and all other strategies and tips and tricks sessions for cracking the CBSE exam as well. There are CBSE exclusive batches as well, and they are in English. So that's the best part. Not like other institutes where they teach you in Hindi plus English, but here we have proper English batches as well. All right, so let's get going. So yes, board is also not that easy. A lot of people ignore it completely. You shouldn't ignore. You should keep it on second priority as compared to JEE or NEET. Remember, as soon as you start preparing for JEE and NEET, automatically your board preparation happens. You should solve the back exercises of NCERT. You should solve the sample papers. You should solve the question banks released by CBSE. You should solve the previous year questions of CBSE board paper. Once you do all this, trust me, nobody can stop you from getting very good percentages. You can easily get 95 above. Alright, so let's get going. Is there Vedantu channel for CET? Rohit, unfortunately no bacha, because there are so many CET examinations. How many channels will launch? And plus, then again somebody will ask, sir, in Telugu we want, sir, we want in English also, we want in Hindi. So it becomes crazy. Understand the bandwidth constraint. Let me tell you, your CET preparation automatically happens when you study for JEE and NEET. Okay? Chalo. Yes, Virag Gaming, that's very true. Kavita, I'm right now in Bangalore, and thank you, Prudvi. And let's begin then. Are you guys full with Josh? Is board exam tough for JEE or NEET? Obviously, Jitesh, JEE and NEET is tough. Board exam is easy. But if you only prepare for boards, then you might find board stuff. When you prepare for NEET and JEE, board is relatively easy. You should just know how to write the answers, points, derivations. You should remember the facts and figures. That's all. Okay? Chalo. Let's get going. Pushpanjali is ready to rock. Manjunath, thank you, bacha. Vira Gaming, don't worry, bacha. Even if you are in state board, these questions will be very, very helpful for you. Hello, Karmu Kilan. Welcome aboard. Let's begin. Yes, let's begin. So here there are 55 questions. So this is going to be a long session, but we will start doing questions quickly. I hope you have seen these questions beforehand. If you have not seen it, still it's okay. And if you are going to watch it in a recorded manner, I would advise you to pause the video whenever required and give it a thought on solving the questions and then look at the solution. Let's get going. Which of the following is not the property of an equipotential surface? Which of the following is not the property of an equipotential surface? So guys, the correct answer, think about it. They do not cross each other. That is correct, in fact, because equipotential surfaces cannot merge into each other. So this is V1 and this is V2. So this is correct. The question says which is not correct. The rate of change of potential with distance on them is 0. That is very true. On an equipotential surface, when you go from one point to the other point to the next point, the potential remains constant. On that, everybody agrees with this? Alright. For a uniform electric field, they are concentric spheres. Wrong. Because uniform field means it will be like this. Electric field will be like this. Equipotential surfaces will be like sheets. These are equipotential surfaces. They are like sheets or planes. So those are equipotential. They are definitely not concentric. They can be imaginary spheres, yes. So if you take a charge like this, all these are equipotential imaginary spheres. So that is also correct. So the wrong answer is C, and the question was which of the following is not correct. Yep, let's get moving. Yes, I have given notes for everything. For those of you who are very new to the channel, first of all, do one small favor for me. Smash the like button and hit the subscribe button. Why hit the subscribe button? So that you will get regular updates on CBSE and JEE. Number 2, when you hit the like button, it gives us the motivation and it's a small Guru Dakshina from you guys towards us. Number 3, on this channel I have conducted all the classes which are required for term 1. So AC chapter is one lecture is remaining. After that, term 1 syllabus is over. You can see all the lectures of physics right on this channel in detail. Even the mains questions, advanced questions, even for NEET and for CBSE, you can use these lectures, guys. So please make use of these classes. They are arranged in beautiful playlists. You will find it in the playlist tab. Alright, so please smash the like button out there. Let's get moving to the next question. So there are two charges at 0 and L. Where would you get 0 electric field? So let's say the two charges are over here. So plus 8Q and you have minus 2Q. So where would the field be 0? Obviously, if their separation is L, the field will be 0 somewhere over here. Reason? This small negative charge will pull, this large positive charge will push. It is far away. Here, the net field will be 0. You can see that. So the pull by the negative charge and the positive charge push will balance out over there. Let's just assume that distance to be x. If that distance is x, obviously this will be x minus L. Now it's very simple. The field due to positive and the field due to negative should cancel out each other. So k into 8q divided by, what is the distance from here to here? It is x square, x basically. So I'll just do x square, and here it is nothing but k into 2q divided by x minus L square. So k goes, q goes, 2 and 8 also goes. So 4 divided by x square is 1 by x minus L whole square. Take roots on both sides. So 2 by x is equal to 1 by x minus L. So shift it there. So 2x minus 2L is equal to x. So naturally x will be equal to 2L, which is the answer. Where is it? Option C. Yep, that's how you need to do. A lot of people, they do a common mistake over here. They take that point over here. Understand, the field won't be 0 here. The field will be 0 here. Why won't it be 0 here? if you take a point here, the positive charge will give a field this way, negative charge will also give a field this way. They won't cancel, in fact they will add. In fact, over here you will see negative charge will pull, positive charge will push. And why on this side? Because the negative charge is small, so you have to be closer to the negative charge, and this charge positive is big, so you need to be farther from that. As simple as that. The next AC class next week, bacha. Alright, done with your NEET, Varun Kumar. Congratulations. I hope you really get a good medical college, bacha. Next question. Yeah, C option was correct. Alright, very good, very good. Hi Anisha Ravi, welcome aboard. Hi Zayed. Oh Zayed, you're done with JEE. Zayed, you're just beginning, bacha. Okay, chalo. Let's get going to the next one. Thank you, Harsha. Okay, so what do we have? An electric dipole moment is placed parallel to the uniform field and the amount of work done in rotating the dipole. Again, standard question, guys. You have a dipole like this and you rotate it and you keep it like this. Initially, obviously, the field is here and this is how it is. This is initial, this is the final position. Now, we all know what is the potential energy in this situation and this situation, because the work done, so that amount of work done in rotating is final minus initial potential energy. The final potential energy, this situation, situation 2, is nothing but minus PE cos 90 degrees, because the angle between field and dipole is 90, minus initial potential is minus PE cos 0 degrees. Recollect, the formula for potential energy is minus P vector dot E vector, PE cos theta, that's the formula. So cos 90 is 0, minus minus plus, cos 0 is 1, so it is just P. So the answer is just P, guys. Option B it is. Yep, how many of you got it? Let me see. Very good. Some of you said A. No, it's not option A, it is option B. Be careful. Okay, so that's how these questions are, direct formula based. Guys, I hope you remember your exam is going to be objective, so I am pretty sure you will nail it if you're preparing for JEE as well as NEET. So guys, I'm really banking on this. You have to score more than 95% in physics. There is no doubt about it. You can score it very easily. These papers are going to be as easy as this, because these are sample papers released by boards. These are official sample papers. All right, let's get moving to the next question. Come on, my warriors, let's do this. If you're ISC, probably the paper will be slightly different or maybe even tougher. I don't know. Okay, so the 3 capacitors are given and the equivalent capacitance. Come on, my warriors, this is so simple. All of them are in series. So in series, you have to add the reciprocals. Don't be foolish to add all of them. 2 plus 3 plus 6. No. 1 upon 2 plus 1 upon 3 plus 1 upon 6. So LCM 3 plus 2 plus 1 divided by 6. 3 plus 2 plus 1 is 6 divided by 6, which is 1. So that is 1 by CS. So CS will also be 1 microfarad. That is the answer, which is option B, my warriors. Okay. No, it is not option A. It is option B. Be careful. Yep. Very good. Let's get moving to the next question. Option B was correct. So there are totally 55 questions, let me tell you, released officially by boards. We are going to solve all of them. So I need to keep your energies really high so that I get the motivation to solve all the questions. 2-point charges placed in a medium of dielectric constant something and some distance is there. They experience some force. Okay, so what you have are basically 2 charges and they experience some force when they are kept in some medium. Okay, so this is the medium. Now, if those same charges are kept in air, what will be the new force? Let's say I call it F1, F1. This was F and F. We all know when you put a charge in dielectric medium, the field weakens. So the field in the dielectric medium is basically nothing but the force divided by K, but this is in vacuum or basically air. So this dielectric medium's force is F, vacuum's force is F1, and dielectric medium constant is nothing but 5. So that's it, guys. The question asked is the new force F1 is 5 times of F. That's the answer, 5F. Where is it? Here. A lot of people might mark this, be careful. That's not the correct answer. The question is the force in air. So it will be 5 times more. Be careful. Very good. Nikhil, be careful. You made a silly mistake. It's not option D. Okay. Yep. Ijal, well, I'll try and reply, Vacha. I cannot assure, but I'll try definitely. Okay. Let's move on to the next one. Which statement is true for Gauss's law? Beautiful question coming up on your screen. Okay. And here we have all the charges when inside or outside the Gaussian surface contribute to the electric flux or not. Well, see, when you draw a Gaussian surface, the flux, okay, is inside charge by epsilon naught. Okay, inside charge. Here it says outside. So outside word is wrong. Do you see that, guys? Yep. Very good. Next, electric flux depends on the geometry of the Gaussian surface. No. It only depends on the charges inside. So whatever charges are there inside, that's all that matters. Even if I take a different shape or the geometry, the flux will still be the same. The flux is same as before because inside charge is same. That's all. Yeah. Gauss theorem can be applied to non-uniform electric field. Now when you apply Gauss's law, if you have it as seen, E vector dot dA vector is Q in by epsilon naught. Every time you derive it, you would have seen electric field comes outside because it makes it easy. This is constant and it makes the integration becomes easy. So you just have to integrate area. So you always apply Gauss theorem when there is uniform field, not non-uniform field, usually. So you would have seen that always E comes outside and then you apply it because then you don't have to actually integrate area, you just need to multiply it with the area term. Alright. The electric field over the Gaussian surface remains continuous and uniform at every point. Yes. So it remains continuous and uniform. Look at that. It's constant and it remains continuous. So whenever you take a Gaussian surface, you make sure that there is electric field on that surface and it is there everywhere so that you can take out E outside. So hence option D is correct. As simple as that. Yep, very good. Yep. So Kavita, I have a Telegram and channel, I will let you know, and that Telegram channel link I'll be sharing it in my micro course which is starting this Monday. So if you have already enrolled, then you are going to get the link as well, where I'll be sharing all the important updates, all the important assignments and all of that. Okay, so that's what you're going to see. Fine, let's get moving to the next question coming up on your screen. Okay, option D was correct and here it is. Okay, Snake Babu, I did my BTech from NIT Nagpur mechanical and then I did my research from IIT Bombay. Okay, let's see how to do this. A capacitor plate are charged by a battery with V volts. Okay, so you have a capacitor which is charged by a battery with some V volts. Okay, after charging the battery is disconnected and what you do, you take that capacitor and okay, you have taken that capacitor and what you have done, you have inserted some dielectric slab in between. So you have inserted some dielectric slab in between of some value K. Now the question is what will happen to the potential? Guys, from here to here, remember the charge remains constant. The charge is conserved because the charge has nowhere to go. Once you disconnect the battery, the charge has nowhere to go. So basically Q is CV. Keep this in mind. Now solve the problem. Once you put dielectric, if the original capacitance was C, what will happen to the new capacitance? It will become K times of C. So if this becomes K times, then what will happen to the voltage? It will become 1 by K times. Why? Because Q has to be constant. The product has to be constant. So this will become 1 by K times. So it will become option C, guys. I hope this is clear. Yep. How dielectric? It is given. A dielectric slab of constant K is inserted in it. So once you insert a dielectric slab, the capacitor ka capacitance will increase K times. Keep this in mind. Okay, Ankit, bacha? Yep, Snake Babu, for IIT preparation also this is very important. Think of this like a revision. Plus, bacha, you have to give CBSE boards also. So for that you need to know all these kind of questions. Don't ignore CBSE board, okay? Because you need to get that good percentage also. Okay, let's get going to the next question. Which is the best instrument? N Kavita, I think you are not hitting the right name for that course. So you need to type in those names exactly whatever I have described in my session which I conducted few days back. So, or just do one thing, just search by Shreyas Sir. Just type Shreyas Sir in add course and just search, you will get it. Okay, that is also fine. Okay, come on my warriors. Which of the following instrument is the best instrument for measuring the EMF of a cell? Well, this is very easy. The answer is A, and most of you have answered it correctly. The reason why it is potentiometer is because it is based on null deflection. Now remember this always in physics. All methods which involve null deflection are very, very accurate. So doesn't matter whether it is for EMF, current, temperature, any kind of experiment. Every time you have a null deflection method, they are more accurate than those experiments which will involve some calculation via some reading. You have to note down some numbers. That will be more, inaccurate. Okay, chalo. Let's get moving to the next question coming up on your screen. My God, Snake Babu, you can ask me these kind of questions in Coffee with Shreyas session. Let's focus, because I went for IIT preparations long time back. That time probably you are not even born. You are not even born when I was studying and when I cleared my JEE. So let's focus on this session, bacha. All right. An electric current is passed through a circuit containing two wires of the same material connected in parallel. If the length and the radius of the wire are in the ratio of this, then what is the current's ratio? Now, it's clearly mentioned that they are connected in parallel. Now, we all know whenever you have resistors, okay, in parallel, okay, let's say this is R1, let's say this is R2, let's say this is I1, let's say this is I2. Remember, the current is always inversely proportional to the resistance. Current is always inversely proportional to the resistance in parallel. This is very, very important. So based on this, I will say I1 by I2 is R2 by R1. Now, we all know what is resistance equal to. Resistance is nothing but resistivity into length divided by area, and this is rho L divided by area is pi r square. So pi r square. R is the radius, A is the cross-sectional area. So can I not write R2 as rho 2 L2 by pi R2 square divided by actually rows are same. Anyways, I'll cancel it later on. Pi R1 square. Rho 1, rho 2 cancel because it contains material, the same material in both the resistances. So same material means rho is same, pi is same, anyways it's a constant. So this will become L2 by, I think I put rho 1 over here by mad. So this is L1, so L2 by L1, and you have R1 square by R2 square. Now it's just a matter of substitution. I think length ka ratio is given. The ratio of length is 3:2. So 3:2. So this is 3, this is 2. Ratio of radius is given as 2:3. R1 by R2 is 2 by 3 square. So 2 cube is 8, 3 cube is 27, 8 by 27, option C. Very good. How many of you got this? Let's see. Very good. Okay. Chalo, बहुत ही बढ़िया, excellent है guys, excellent है. Yep. So no need of Ohm's law also. There is, although this is dependent on Ohm's law, but current is inversely proportional to resistance, and resistance is rho L by A. Area is pi r square. 3 formulas. That's it. Take the ratio. Yep. Answer C. That's correct. Beautiful. Very good. Understood. Yes, Zayed, it is visible. All right. And here we go. Next question. By increasing the temperature, the specific resistance of a conductor and a semiconductor this is something which you should know as it is. Okay, whenever temperature increases, the randomness increases, energy increases, and for a conductor, you will see the resistance will also increase. But for a semiconductor, they have negative, okay, for a semiconductor they have negative coefficient of thermal resistance. You will see semiconductor resistance will always decrease, because those electrons which are now in the valence band will now be able to jump to the conduction band, which you will learn this in semiconductor. So more electrons are available for conduction, so that's why the conductivity increases. Okay, so yes, it is not D, it is C. Increases for a conductor and decreases for a semiconductor. So when you increase the temperature, resistance for copper, aluminum, iron increases. For semiconductor like germanium, silicon, all of them, it will decrease. Keep this in mind. Semiconductors have negative coefficient and conductors have positive coefficient for thermal resistance. Next question. Okay. N Kavita, do one thing. See, I had conducted one class on YouTube. Please watch that class, guys. You will be able to see my courses very easily. It's over here. Where is it? Yes, Enthuse on vPro, biggest gift. Over here I have explained it. So after the ad probably you can see that. Okay, I have explained it, how to search for my course and how to add the course, etc. Everything has been mentioned over here. Okay, how to add the course, everything has been mentioned. So just check this out, check this lecture out, probably this will help you. Okay, is it fine? Cool. Okay, all right, let's get moving to the next one. All right, let's get moving. And we use alloys for making standard resistors because they have. Why do we use alloys for making resistors? What is the speciality about it? Come on, think about it. Yep, think about it. Let's see. Come on, my warriors. Let's see. Okay, good evening, Arpan. Welcome aboard. Okay, some of you are saying A, some of you are saying C. We use alloys for making standard resistances because reason is when you want a resistor, you don't want the resistance to change. The resistance should approximately remain constant. That means they should have low temperature coefficient. Yes, they should have low temperature coefficient. You don't want when the temperature changes, resistance also changes significantly. That will affect the performance of the device. It will give you unexpected behavior. So low temperature coefficient. And because these resistors are very small in size, so you want decent amount of resistance in that small size. That means they should have good resistivity. So high resistance should be there in that small volume, because resistance is rho L by A. If you have a small resistor, you want a very high resistivity device or material to give that high value of resistance. Hence option A. Yep. Let's move on to the next one coming up on your screen. Good evening everyone. Those of you are joining in late, come on, join in bacha log. Do not forget to smash the like button and hit the subscribe button out there. Okay. A constant voltage is applied between the two ends of a uniform metallic wire. Heat is it is H. If another wire of the same material, double the radius, twice the length as compared to the original wire is used, then what is the new heat developed? Achha, interesting. Let's see. Okay. Glad to know that, Mahra Hassan. Welcome aboard. And this is an English medium channel. So all our lectures over here in the playlist and videos are all in English. Okay, so what is the value of heat? How do you get the value of heat? Think about it. I think you can use power loss is nothing but V squared by R. So heat will be P into time. So this will be V square by R into time. Now it is connected to the same battery, I guess. Okay, but only the material has been changed. Oh, what do we do now? Resistance. Resistance is rho L by A. Use that. So this will be V square T. This will be rho L by A. But wait a minute, what is area? Area is nothing but pi R square. And here you have rho into L. Most of these terms are constant except for R and L. Yes. Look at this. This length has been doubled, twice the length. So into 2 times. Radius is also doubled. So radius square is becoming 4 times. Numerator became 4 times. Denominator became 2 times. As a whole, this ratio will become how many times? 4 by 2, which is 2 times. That's it. So hence, whatever heat was there, that heat will become 2 times. Hence, the correct answer is C. I hope this is clear. Bhargav, I completed kinematics entirely long time back, bacha. Yep. Yes. So, when you use I squared RT, bacha, Selva, I is not same, I is not constant because the battery external voltage is constant. So, current will change when the resistance changes. So, do not use I square RT, use V square by RT. Okay. I hope this is clear. If you have not applied for KVPY, Arsha, you cannot do anything. Leave it, concentrate on boards and concentrate on G. Okay, let's move on to the next question coming up on your screen. Remember, it is clearly mentioned constant voltage is applied. So make use of that fact, not constant current. If current was constant, then you will use I squared RT. I hope that is making sense. Okay, chalo. Okay, so Zayad, I don't think we need to launch those kind of series right now. We have more important stuff to do, like KVPY is around the corner, plus we have JEE Advanced around the corner, plus your board exams are around the corner. So for that, we need to make sure you are very well prepared for the examination, bacha log. Okay, let's get going to the next one. Now, if the potential difference is applied across a conductor and it is increased to 2V, with the temperature kept constant, then the drift speed of the free electrons will. Let's get going. Okay, so what do you need to do? Okay, potential difference is applied across a conductor and it is increased and temperature is kept constant. Acha, what is the meaning of this? Temperature is kept constant means resistance is constant. Okay, and if I use that formula, I is equal to NVIDIA. I is equal to NVIDIA. And V is equal to IR. Therefore, I'll get, substituting it over here, NVIDIA into R. Now, remember, voltage is made twice. So the voltage becomes 2 times. N will be constant, E constant, area constant, R constant. So obviously, drift speed should also become 2 times. If LHS becomes 2 times, naturally RHS should also become 2 times. That's the answer. So it will be double of the initial value. NVIDIA trick. Yes. Remember NVIDIA, it's a mnemonic. Okay, it's also the name of the graphics card company. Be double of the initial value. Moving on to the next question. Very good, Nikhil Krishna. Excelente, Hariharan. Very good, Selva. Very good. Arvind, I think, yeah, that is C. Okay. Hi, Ashwini. Welcome aboard. Now, these kind of questions are also very common in JEE mains. This is disguised form. Okay, what kind of form is this? Disguised. Remember this, whenever you see this, this is disguised form, and mark the potentials. This is wire. Okay, if this is a wire, this is also point A potential wise. This is also point A potential wise. This is B, this is a wire. This is also point B potential wise. This is also point B potential wise. This is something else. So this is, let's say, point C. Now redraw the circuit. That's it. Start from A. Start from A. What do you get? 1 resistor, 2 resistor, 3 resistors. So there are 3 resistors. Okay. So I'll just draw 1 resistor, 2 resistor, and 3rd resistor. What are those 3 resistors? 3 ohm, 6 ohm, 3 ohm, 6 ohm. Okay, I'll just put probably 3 ohm here, 6 ohms here, and there is one more resistance. You can see 30 ohms here. Okay. Great. Now the 3 and 6 ohm are connected to point C. Look at that. The 3 and the 6 ohm are connected to point C. Okay, 3 and 6 are connected to point C over here. That is point C. This is point A. C is connected via a resistance to point B. Acha, C is connected via a resistance to point B. How much is that resistance? 8 ohm. Also, this 30 ohm is connected to point B. Acha, that means this one. This is connected to point B. Now this is very simple circuit, easy circuit now. Just mark the potentials and you will get the answer. First of all, the equivalent of 3 and 6 will be 3 into 6 divided by 3 plus 6. 6 3 is 18, 3 plus 6 9, 18 by 9, 2 ohms. 2 plus 8, check this out. So 2 plus 8 ohm, these are in series. That will become 10 ohm. 10 and 30 are in parallel. So resistance between A and B will be 10 into 30 divided by 10 plus 30. So that will be 300 divided by 40. So that will become 3 by 4 is 0.75 into 10, 7.5 ohm. 7.5 ohm, that is option C, guys. I hope this is very, very clear. Can we go ahead? Okay, how 3 and 6 are in parallel? You can see that they are obviously in parallel, like 3 and 6. Can you see that? See this point, this point, this point, this point. Obviously they are in parallel, same voltage difference. The current will get distributed here and here. So obviously 3 and 6 are in parallel. Their combination is in series with this. And this whole branch is in parallel with 30. I hope now it makes sense. Yes, EGL, you can see it, but provided you know the theory. If you don't know the theory, then probably it will go over your head, bacha. Okay, now is it clear, everyone? Renu Pandey, is it clear? Why is it in parallel, bacha? Let's get moving to the next one. Okay, chalo, that's the answer, 7.5 here. Bhavani, I think you missed a lot of questions, 14 questions you missed, but watch it in the replay. Now continue with the 15th question. If you are joining in late, it's okay. Watch the missed part later on. Okay, here is the next question. That's very surprising. 12th standard students are supposed to attend this and 11th standard students are attending. Very interesting. Okay, so SI unit of magnetic field intensity. Magnetic field's intensity is nothing but B. Try and recollect a formula which helps you with magnetic field and newtons and meters and all of that. VSK Chaitanya, don't expect first attempt in January. In fact, expect it in February or March. Okay, so I can say force is equal to I into L into B. You know this standard formula. Force acting on a current carrying wire. Force is in Newton, current is in ampere, length is in meter, and magnetic field is what you want to know. So magnetic field's unit will be Newton per ampere per meter. So Newton per ampere per meter, that is option B. Yep, that's it. Very good. That's all. You just need to remember a formula. Oh my god, Arvind is also in 11th. So it's okay, bacha. You can watch it. Probably you will get to know some new formulas. Don't worry if you don't understand few formulas, you will learn it in 12th. Next question coming up on your screen. Okay. Kassan, I'm teaching a lot of micro courses for the 11th standard batch, bacha. So in fact, if you just search on Google, Shreyas Sir Pro subscription, you will get the list of all the courses special courses I am conducting. See, regular batches, you already have teachers, but my expertise is also there in Erudov course, HC Verma and derivations and all of that. So for that special courses, I am there, so you can check it out. Okay, even the 11th standard ones. Okay, so just search it on YouTube, you will get the video. From the video, you will get to know how to join and get enrolled into my courses. The coil of a moving coil galvanometer is wound over a metallic frame in order to do what? So the answer for that, a lot of people are saying B. Interesting. Well, the correct answer is actually D. See, I'll tell you what happens. That's why I put up this diagram over here for you guys. In a moving coil galvanometer, there is a coil and it is wound on a drum and it can rotate, okay, about this axis. There is external magnetic field by this cylindrical magnet. So when a current passes through the coil, the magnetic field will deflect this coil. Accordingly, we will be able to measure the current by the numbers on the scale. Now, if you do not have electromagnetic damping, what will happen is that when you supply current, suddenly there is a torque, and because of the torque it will go like that and it will oscillate. Tuck, 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 it will oscillate. You will be like, wait, what is the reading? What is the reading? So you don't want to do that. You want, once you give current, it should go there, it should go and stop. So that damping, what is damping? It should suck away that energy. So that sucking away of energy happens because of this metallic frame. So the moment you have this metallic frame over here, what happens is there are eddy currents which are produced. Eddy currents. And what do eddy currents do? Eddy currents cause heat loss. And because of this heat loss, they suck that energy. They suck that energy. And because of that sucking of that energy, there is damping. It basically stabilizes. It stabilizes easily. So this is the flow that you should remember. Hence, this is the correct answer. Okay, I hope this is clear. Achha, what does hysteresis and other things mean? Increased moment of inertia, that has no meaning over here. Sensitivity does not increase because of that. Sensitivity depends on number of windings, field and spring constant and all of that. Hysteresis is basically how much energy is lost when you magnetize and demagnetize it. When you magnetize something and demagnetize something, you will not have net zero energy. Some energy goes in the total magnetization and demagnetization, even if you are trying to bring it to the original state. So that is called as hysteresis. So hysteresis has no role to play because you are not magnetizing and demagnetizing. When you pass the current, the coil just deflects because of the external field. This problem comes in transformers. This is the reason for transformer, to reduce the hysteresis loss in transformer. So this option is just given to confuse you guys. Okay? Let's get moving to the next one. All right. I hope EGL now it is briefly understood. You will learn about hysteresis in transformers. All right. Moving on. Two wires of the same length are shaped into square and circle. Okay, if they carry same current, the ratio of the magnetic moments are. Guys, don't believe me, this kind of question came in JEE mains. Yes, this came in JEE mains. Very similar question. So very interesting to see JEE mains kind of questions coming in CBSE. Well, first of all, when you convert it into a circle of radius r, the perimeter, which is L, will be 2 pi r. Okay. Now, what is the magnetic moment of that circle? Well, the magnetic moment of that circle will be NIA, N is 1, I is I, into area. Area is pi r square. Now, you can see from here, r is L by 2 pi. So, it will be L divided by 2 pi whole square, which is I L square by 4 pi square. That's for a circle. Similarly, for a square, okay, the side length is A, imagine. So the total perimeter will be 4A. Remember, the same wire or same length is converted once into a circle, once into a square. So the perimeter for both these diagrams is the same. Keep this in mind. What is the magnetic moment for that square? N is 1, number of turns is 1, current is I, into area. Area is A square, side square, which is L by 4. Look at this. The side is L by 4. Okay, so that's the side. L by 4 square. So this will be I L square by 16. Now the question says once into a square, then a circle. So what is the ratio of this magnetic moment of that square divided by magnetic moment of the circle? Now this is very easy. You can get this. Square is I L square by 16. This is I L square by 4 pi square. So what you will have is this 16 coming below, and you will have that 4. Oops, this pi and this pi will get cancelled. There is one more pi over here. So this pi will get cancelled, guys. And what I will have is just 4 pi over here. And now you can cancel this 4 and this 16. This will become 4. So pi by 4 should be the answer. Look at that. Option C should be there. Let's see. Yep. Very good. Very good. Option C. Glad to know that, Mahira. Okay. I wish to see you and Suri sir once on the screen for sure, bacha. Definitely, someday or the other. Okay, these kind of questions will come for board. Jumila P, yes, bacha. This is actual official. This is official paper available. This is released by CBSE. I am not making these questions up. I have not made these questions. These are actual official questions released recently. Last week only they released, and they told this is your sample paper. Expect these kind of questions. That's why we are doing it, because I want you to get good marks, bacha. है ना? So at least sample paper तो कर लो. If you do sample paper, then only you will get to know what kind of questions will come. Else it will be a shocker for all of you. Okay? Chalo bacha log. Let's do this. Next question. Okay, come on my warriors. Let's do this. A horizontal component of Earth's magnetic field at a place is √3 times the vertical component. What is the angle of dip? Even if you don't know what is angle of dip, trust me, you will be able to do it ऐसे ही. मतलब there is nothing great about it. This is horizontal, this is vertical. This is horizontal, this is vertical. This is your total magnetic field. This is your angle of dip. That's it. Now you just need to think what is given. The horizontal is √3 times vertical. That's it. So what is tan theta? Tan theta is BV by BH. BH is √3 times, so this will be 1 by √3. So theta is how much? 30 degrees. So 30 degrees means pi by 6. That's the answer, guys. As simple as that. Yep. Sir, if you prepare for JEE, then don't care? No. It's not like don't care. You don't have to worry too much. It's not like don't care. You have to care. I mean, you need to solve previous year questions and back exercises, but you don't have to spend a lot of time. Okay, there is a small difference. Okay, this was easy one. Let's get moving to the next question. Okay, the small angle between magnetic axis and the geographic axis at a place is called, come on guys, this is something everybody should get. Oh my god, many people are making a mistake. Guys, meridian does not mean a line, it means a plane. It is a plane. So magnetic meridian is not even an angle. Magnetic meridian is a plane which contains magnetic field and magnetic axis. Geographic meridian is a plane which contains geographical axis and the point. So these are not even correct. The question is angle. Now magnetic inclination or magnetic declination. The correct answer for this, okay, oh my god, EGL, you have not yet learnt it, you are still in 10th, you will learn that in bar magnetism. Watch my lecture on bar magnetism. I have conducted this class, okay, bar magnetism and Earth's magnetism. So the magnet actually points somewhere else than the true north. That difference is called as declination, because where the actual north pole is, you won't have the magnetic pole over there. The magnetic pole is somewhere else. It's very close to the actual pole, but somewhere else. So that's why there is a small difference, that is declination. Also, at a place on Earth, the magnetic field is not horizontal. There is vertical and a horizontal component. So that angle which vertical and horizontal make with each other, that is that, you know, angle of dip that you get over here. Okay, so angle of dip I just told you, BV, BH, BV by BH gives you tan theta. Okay, so that's what it is. And the angle between magnetic meridian and geographic meridian, magnetic meridian and geographic meridian is called as the declination angle. Keep this in mind. Yep, very good. I know Arvind, I have janbujh ke showed you the solution because I want you to see what is it. Because all these four terms you should know what is it. Okay, so magnetic plane, read meridian, meridian as plane, keep this in mind. Meridian is a plane, not a angle or an axis, keep this in mind. Okay, what about this? This is also straightforward. Though coil placed close to each other, the mutual inductance of the pair of the coil depends upon what all things? This is very easy. Okay, so Ram Kailash, you should look forward for, you know, refreshers, previous year questions, and also NCERT back exercise along with school or your college notes. Okay, that's what you need. Okay, a lot of you are saying A. Interestingo. Actually, it is not A. It only depends on position and orientation. I have told you mutual inductance. So when you have two coils, okay, when you have two coils, this is creating some field around it. Okay, how much flux passes? This M depends on the geometry. It depends on the shape. It depends on the size, basically. So geometry means, you know, position, orientation, how you are orienting it. That's all. Okay. So if you change the orientation, the number of lines cutting through it will also change. Okay. So that's what it is. Hence, the correct answer is B. A conducting loop of certain side length and resistance is moving in a plane where uniform velocity, it has uniform velocity and there is magnetic field perpendicular and it is uniform in time and space and it is going inside the plane of the board. So it is everywhere. So what is the current induced in the loop? Very straightforward question. Very straightforward question. Come on. Just increase your resolution. Sub G, just go to the settings. Increase the resolution to 720p. What is the answer? Very straightforward, guys. Come on. Guys, think there is magnetic field everywhere. So the number of lines which are cutting inside, that flux will be constant. So d phi by dt will be 0. That means EMF will be 0. That's it. The answer is 0, guys. Yup, it is D. Looks like only one or few people got it. No, it is not B or A or anything else. Okay, so it is actually D. Yep, it is 0. The flux is constant. Everywhere same field is passing. So whether you take it here, 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 doesn't matter. Answer is D. Moving on to the next one. Again on Faraday's law. So flux is 5t square plus 3t plus 16. Calculated at time t is equal to 4. What do you think is the induced EMF in the coil? Come on, my warriors, you can do this. It's just based on Faraday's law and derivatives. You can do this very easily. EMF induced is minus d phi by dt by Faraday's law. So it will be minus d by dt of 5t square plus 3t plus 16. So which will be t square's derivative 2t. So minus 10t, 3t is derivative 3 but with the minus sign and 16 is a constant. Now this is EMF in general. So EMF at 4 seconds will be minus 10 into 4 minus 3. Because time value will put it as 4. So this will be minus 43. So is it there? Yes, option B. As simple as that. Excellent. Very good. Let's get moving to the next one. Option B is correct. Okay, before we go ahead to the next few questions, let me tell you guys, if you are interested in joining the CBSE batch which is running right now in Vedantu, you're still free to do so. The classes will look like this, with MCQs, with chats, also with a second teacher in the chat box to consistently solve your doubts. So there are always two teachers in the class. One is actually teaching and there are these amazing leaderboards where you compete with your teammates and your classmates out there. And also there is second teacher who is not seen but he solves your doubts. So that's our wave platform, which is very interactive, filled with lots of fun quizzes, leaderboards, so you can compete real time and you get to know how well you are performing in the class. Because in your regular batches, maybe in your school, which is conducted on Google Meet or Zoom, there is no input on how you are doing. You might sleep out there, but here you get all that data points. Alright, so let's go to the 23rd question. There are 55 questions, let me tell you. Which of the following graphs represent the variation of current versus frequency in an AC circuit containing pure capacitor? This is simple. So current will be voltage divided by XC. This is capacitive reactance, and capacitive reactance is 1 by omega C. So this will become V omega C, but omega is nothing but 2 pi F. So that is the current. Now clearly you can see frequency and current both are on the top. So current is directly proportional to frequency. So there is only one graph like that, and that is option C, guys. Done, done, done. Very good, Selva. No, Deepak, it is not option A. Okay. All right. You want to see me in the Menti quizzes? Soon I'll conduct a Menti quiz next week. Don't worry, bacha. Okay. Going on to the next one coming up on your screen. 20 volt AC is applicable to a circuit consisting of a resistance and a coil. Negligible resistance. If the voltage across the resistance is 12 volt, then the voltage of the coil is how much? Okay. So understand this is based on vector or phasor diagrams. There was a resistor and there was an inductor. Coil is an inductor and you have a AC circuit. And now, okay, so you have a resistance voltage which is given to be 12 volts, okay, and you have the AC voltage to be 20. So the question is, how much is the voltage across the inductor? So again, by Pythagoras theorem, you will get VL is nothing but 20 square minus 12 square. So this is going to be 16 volts. Okay, option A. Still it will be option A. Yep. I hope this is fine. Even if the question had a capacitor, still the answer would be same, guys. It won't change because there is only one device. But when capacitor and inductor both are there, then the answer would have changed. Yeah. Okay. Clear? Cool. Let's get moving to the next question. Achha. It is not D. It is not D. Okay. Yep. The instantaneous values of EMF and current in a series AC circuit are given as shown. Then what kind of circuit it is? Here you can see that if voltage is sine omega t, okay, if voltage, let's say it is sine omega t, this is EMF, the current is ahead. The current is ahead by 60 degrees. When will this happen? Well, in two cases. Always draw current in the horizontal direction. There are two cases when this can happen. Think when. One, when there is voltage across the resistor, and by the way, let me also show the EMF. EMF is here. The total EMF is here. Okay. This is the EMF. There are two cases. When you have a resistor and when you have capacitor. Or when you have a resistor, you have an inductor. So this is the voltage across the inductor, but the voltage across the capacitor is very large. Voltage across the capacitor is very large. So net EMF comes this way. So this is a RC circuit and this is a LCR circuit. In both the cases it is possible. So it can be either of them. Yep, this can be either of them. Okay, I hope this is clear, guys. Everyone clear about this? Yes, the option is D. Both the cases you will get the voltage is behind the current. Okay, that's it. Great. Let's get moving to the next question. Option D is correct. Now, here we have, good evening Sai Telugu. Here we have a cylinder of radius r, length L placed in a uniform field. The total flux for the surface of the cylinder. This is such an easy question. Guys, the field lines are just passing like this. Whatever is coming in is going out. So the total flux obviously should be 0. Done, done. There is nothing great about it. Very good, Selva Karthik. Excellent. Excellent. This was straightforward. There is nothing great about it. Okay, moving on to the next question coming up on your screen. Okay, so here you have some calculation. Okay, chalo. Just request you to please put live stream with 60 FPS. My God, GameX Emperor. What are you going to do with 60 frames per second? Like there is some game happening and am I doing some action where you want to see me in slow motion? Okay, so two parallel large thin metal sheets have equal surface densities of opposite signs, the field between the sheets. Okay, straightforward question. There are two sheets, okay, and they have equal surface densities of opposite signs. So if this is positive, this is negative. So due to this, the field will be here, and due to this also the field will be here. So the net field will be adding up each other. Okay, net field will be adding up each other. So all you need to do is the net field will be E plus E minus, and this is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So this will be sigma by epsilon naught. Now substitute the value of sigma and epsilon naught. That's it. Yeah, that's all you need to do. So what is that sigma given? 26.4 into 10 to the power minus 12, and epsilon naught is 8.85 into 10 to the power minus 12. These two will cancel. 26.4 by 8. 8 4s are 20, 8 3s are 24, 9 3s are 27. So it will be somewhere in the range of 3 only. Okay, somewhere close to 3. So option D will be correct. Yep. Okay, very good. CB Singh, I don't know about that book, bacha, because it's not a standard book, okay, which nobody uses for physics at least. So I won't talk about it. Let's get moving to the next question coming up on your screen now. Yes. Yeah, exactly. Who is CP Singh? Consider an uncharged conducting sphere. A positive point charge is placed outside the sphere. The net charge on the sphere is then. Well, here is what you need to do. Consider an uncharged conducting sphere. A positive point charge is placed outside the sphere. So if you have a sphere and if you have a positive point charge over here like this, and this is a conductor, then you will see negative charges getting induced here and positive charges getting induced here. These are all induced charges, but the total induced charge will be 0 because the electrons move from here to here. So the total charge just gets distributed, net charge remains 0 only. So the answer is option D. Yep, it is not A. Okay, so that's the answer. Okay, so I'm not aware of CP Singh bacha, so there's no point talking about it. Let's move on to the next question. Come on, my warriors. Come on. Yes, option. Okay, let's get moving to the next one coming up on your screen. 3 charges are there on the vertices of a triangle. The value of electric field and and potential at the centroid of the triangle will be, this is your triangle, and the charges are minus q, and plus 2q. Now what will happen, guys? This point is equidistant from all of them. This is equal. Let's say that is D. So the total potential will be K 2q by D plus K minus q by D plus K minus q by D. So the total potential will be 0. As simple as that. But the field won't be 0. I'll tell you why. Because this 2q charge at this point will give a field here. So this is the field due to 2q. This negative q will give an attractive field like this. And this negative charge will also give a field like this. So the net of all of them will be downwards. And this will definitely not be 0. So V is 0, but E is not 0. So that's option C, guys. Yep, very good, Swarlina. Excellent. Moving on to the next question coming up on your screen. Okay, yes, option C. Moving on here. All right. No, Sonam, it is not D, bacha. Okay, similar to H.C. Verma question. Okay, so what do we have over here? So there are 2 parallel plate capacitors, X and Y, have the same area, and separation between them is also same. X has air, Y has dielectric. They are connected in series. Okay, so this is X, this is Y. We call this as X, this is Y. This has air, and this has some dielectric over here. Okay, it's given. This is some dielectric, and of constant 2. So if K is equal to 2, then they are connected in series to a battery of 12 volts. Okay, they are connected in series to a battery of 12 volts. Fine. The ratio of the energy stored in between them. Okay, so in series, remember, the charge is same. The charge, no matter whether there is a dielectric or not, charge is same on both the capacitors. So let's use our formula. Okay, what is our formula? Potential energy stored in the capacitor is q square by 2c. Therefore, I will say ux divided by uy will be just the ratio of the capacitance inverse. So it will be Cx divided by Cy. Q is same, 2 is constant. Anyways, so Cy has a dielectric of constant 2. So this will be 2 times of Cx. Think about it. Why is this 2 coming? Because K is equal to 2. Hence the answer is 2 by 1. Done. Option C. Can we move ahead? Let me know. Yes, very good. Yep, let's get moving. Okay, so Moving on. Muthu, what do you want me to reply, bacha? If you write your query once and properly, probably I'll respond. And if it is relevant to the flow of the class, probably it will be better. Okay? Or else leave a comment after the video ends, Muthu Kumar. I'll definitely respond to your query. Okay. Yes, very easy then, Ji. I know Manan Chaudhary. Moving on to the next one. This is CBSE Anna Nagar. Guys, you don't read or what? CBSE Physics Sample Paper Discussion. Read the title. It's there below. Physics CBSE Sample Paper Discussion is given. Official paper released by CBSE, and it's a mock paper. This is the only one of its kind. 55 questions are there. You need to solve this for the term 1 CBSE examination because it's going to be of objective type. Okay. Which of the following is not a cause of power loss in a transformer? This is very straightforward. Lalit, you can go behind and you can replay the same part even in the live class. Just take the slider behind, you can watch it again. Okay, just do that. So this is straightforward. The eddy currents in the soft iron core produce heat losses. So this is a cause of loss. Eddy currents. Okay, eddy currents is a cause of loss. This is correct. There is no doubt about it. The question says which of the following is not a cause? Electric flux is not properly done from primary to secondary. Whatever flux is created from the primary, it should go here. But some of the flux might leak. There might be some leakage of flux. So if the flux gets leaked out, there is no proper coupling between the primary and secondary. So the EMF generated on the other side might not be good enough. So there is some flux loss because some lines might go out. Okay. Humming sound produced in the transformers due to magnetostriction. What happens is, because this is AC, what happens is when the current changes the direction, magnetic field also changes the direction. When the magnetic field changes the direction, this is what happens. Look at that. Inside, the atoms also change their orientation. And once the atoms change their orientation, the structure of that particular coil and that iron core also changes rapidly as the current fluctuates. And as this happens, you will see the structure starts vibrating. And because of that vibration, you get that humming sound. That is called as magnetostriction. Is that now clear? Okay. I hope this is clear. Ria, there is nothing like sure shot for advanced, let me tell you that. Advanced is a very unpredictable exam. So there is no point to doing sure shot for advanced. Okay. So no point. Okay. Yes, Nitish Kumar, even if you have wasted 11th standard, you can get 90% in 12th standard. If you prepare very well, follow our classes regularly, don't give up and stay motivated. Even now you can get 90% and above. Okay. Yes, GameX, I have made a lot of sessions. Check my strategy session for 12th standard JEE 2022. Check that out on YouTube. You will find all the lists of all the books. Okay. Primary coil is made of thick copper. In fact, this is not a reason. When you make it of copper wire, in fact, it will not make any loss. Copper wire is a very good conductor. So it will not cause any loss. Hence, D is not correct. Okay. Even for 2023, there is a lot of time. 2023, there is a lot of time. You can definitely catch up. Okay. An alternating voltage source of variable angular frequency and fixed amplitude is connected in series with a capacitor, and there is a bulb. Guys, this same question I just did it. Honestly, I'm telling you, a few days back. Anyways, if you have been attending my lectures, you would know it. So you have a voltage source and you have connected it to with a capacitance and a bulb. So this is a capacitance and a bulb, and this is our AC source. Okay, this is your bulb of some resistance. Now, when frequency is increased, omega will increase. And XC, what is XC? It is 1 by omega C. So if omega increases, then XC will decrease. Now if XC will decrease, then impedance will also decrease. If impedance decreases, this is the total resistance, okay? So then the current, which is the voltage divided by Z decreases, current increases. If current increases, power loss in the bulb, which is I squared R. So if current increases, power also increases. If power increases, the bulb will glow brighter, more heat, more light will be there because of more power, higher wattage, more power. That's the whole idea. Okay? Yes. So that's how it is. Very good. Very good. That's how you need to do this question, guys. So the correct answer is option B. Yep. That's the answer. Enjoying these questions, guys? Guys, did you smash the like button? Yeah? Did you smash? We are discussing 55 all official questions released by CBSE just few days back for your term 1 12th standard examination. Even if you are 11th standard student, you are free to attend. But if you are a 12th standard student and you have your friends, you should first of all get them onto this platform, guys. I'm very disappointed with you. You guys are not getting your friends. Come on, you should do that. You should motivate. Don't think if somebody watches this channel, then they will get more knowledge and then they will score well, then what will happen to my rank? Never think like that. Don't be selfish. The moment you become selfish, in fact, you will score less. The moment you start helping others, you will see you will score even better. Trust me on this. This is how life works. Okay, come on, my warriors, let's do this. A sphere, charge q, surrounded by minus q. Inner radius 2r, outer radius 3r. What about potentials and fields? I'll tell you what. Inner sphere is charged plus q, right? So the positive charge will be here. Okay, this is where the positive, okay, plus q charge will be. Exact amount of minus q charge will be here. Okay, exact amount of minus q charge will be here. And the outer surface will have zero charge. Outer surface will have zero charge because minus q on the inner shell plus q on this inner solid sphere. Outer shell will have zero charge. This is very important. Now, the field will be only there from here to here. Look at that. The field will be only there from here to here. This is the electric field. Here, field is 0. Here also, the field is 0 because this is a part of the conductor. That means, think about it, always potential travels from, or rather, sorry, field travels from high voltage to low voltage. So that means this is high voltage, this is low voltage. So, and because the field is 0, everywhere the potential is constant. Everywhere this is V high and suddenly it becomes V low. So the potential is highest on this region B and even the field is splitting. Look at that, the field is going like this. Here the density is more. So this is high field. This is low field. So the field is also high at B. So both field and potential are the highest at a point B. Yes, that is the answer. A lot of people make a mistake over here. So both the potential and the field are the highest. Option D. Yes, Selva Karthik. No, Swarlina. Electric potential has maximum magnitude at D? No. Electric potential does not have maximum value at D. It has maximum value at B. Be careful. Okay. So potential is always high from where the field originates. So field always travels from high to low voltage. Okay. Fine. Okay. Chalo. Let's moving on to the next question. A battery is connected to the conductor of a non-uniform cross-sectional area. Which quantities will remain same? This one is easy, guys. Yep, no problem even if you guys made a mistake. So this is your non-uniform cross-section. So what happens? The current which flows will be the same. Whatever current comes in has to go out. Everything else will change. Drift speed will change, field will change, electric field and current. Electric field will change. Only current will remain same. That's the answer, as simple as that. Because whatever charges come in have to go out in that same time. There cannot be accumulation of charges. They cannot crowd over there. That's the reason for that. All right. Option D. Moving on to the next one. Yes, Nimmalan, why not, bacha? Okay. What's the difference between normal chat and super chat? In a super chat, Oh my god, Arvind Kumar has put up a super chat. Oh my god, what is Arvind Kumar's chat? Arvind Kumar, thank you bacha for all the love, and I'm not sure what was your chat. I think I missed it. Oh my god, I'm so humbled for putting up that chat. Shalini, the field changes because field is rho into J. J is current density. As area changes, current density changes. As current density changes, field, which is rho into J, will also change. That's the reason for that. Okay, let's get moving to the next one. GameX, there are 55 questions. Okay, let's figure this out. There are 3 resistors in series. Okay, so you have R1, R2 and R3. Okay, this is R1, R2 and R3. R2 has 3 ohm resistor. Current through this one is how much? 2 amperes. By the way, whatever current flows here will also flow over here. There is nothing great about it. I mean, 2 amperes will only flow everywhere. And R3 has a power loss of 6 watt. Okay, so power loss across 3 is 6. Power loss is I squared into R. This is 6. And I is given to be 2. So therefore, R3 will be 6 divided by 2 square. 6 by 4, which is 3 by 2 ohm. But the question says, what is the voltage across R3? So the voltage across R3 will be current into resistance. Current is 2. Resistance is 3 by 2. So 3 by 2. So hence it will be 3 volts. Is it there in the option? Yes, it is. Option C is the correct answer. As simple as that. Very good. Very good. Thank you, Arvind, and thank you guys for putting up the right answer. And I joined and I saw the class of 12th. Pushpanjali more, let me tell you, bacha, there are 11th standard classes also for you guys. What is it called? Nurture series. Come on, my warriors, you should be helping all the 11th standard students, and if there is a 12th standard student, you should be like, Shreyas Sir, classes are already there. 12th standard classes are called Pathfinder. You will see it in the playlist. 11th standard classes are called Nurture series. And other series are for passing out students who are right now going to give J Advance and all of that. Okay, chalo, moving on to the next question. Answer was 3 volts. That's correct. Moving on. Yeah, this one is very crazy question actually. Let's do this. Okay, current versus the voltage across a battery. So whenever you have a battery, guys, okay, whenever you have a battery, think of this battery, you know, like a small internal resistance and an ideal battery. That's what it is. Okay, that's what a battery is. So if there is some current I over here, the voltage drop across a battery is actually this EMF. Let's say this is E, this is internal resistance R. So this is E minus IR. This is a standard equation which you should know when current is being pulled from a battery. Keep this in mind. Now, check this out. When the current is 0, okay, when the current is 0, first situation, when the current is 0, the voltage is 5.6. So E is nothing but, therefore E is nothing but 5.6 volts. Okay, but that's not what is asked. Question is, what is the internal resistance? Second equation. When the voltage is 0, okay, just put voltage is 0. E is E only, which is 5.6 minus the current is 2 into R. Therefore, 2R is equal to 5.6. Therefore, R is equal to how much, guys? 2.8. Yes, that should be there. 2.8 ohms. That's the answer. As simple as that. It was just graph reading. Forget the other points. Just concentrate on these points. As simple as that. Very good. Excellent. That's it. Okay. Chalo. Let's move on to the next one coming up on your screen. Okay. Now this one is good question. Okay. Many people will make a mistake. But let's not make that mistake. See, balancing length is 600. The question says what is the value of the unknown EMF. External resistance is also there. Battery is also there. This circuit, trust me on this. Forget this, because At null point, the current will be 0. At null point, the current will be 0. So there is no current here. Only thing I know is the potential difference. So this circuit is actually similar to 5 volts as it is, and from A to J is one resistor. This is A, this is J. From J to B, okay, from J to B is another resistor, and from B to this point is also one resistor. Okay, this is another resistor, and that's it. And this resistor is 480 ohms. 480 ohms. This wire is divided into two parts. The total resistance. What is the total resistance? It is 20 ohm. The total resistance is 20 ohm. So this plus this is 20 ohms is something what you should understand first. Aren't you seeing these three actually are in series? And according to the given question, okay, now what is given? Yeah, the balancing length is given. Where is the balancing length given? Yes, where is it given? It is, yeah, it is 6 meters or 600 centimeters. Now, for 10 meters, look at that, the resistance is 20. So, for this much length, how much is the resistance? Very simple. Raj is 6/10 or 6 meters by 10 meters into 20. I hope this makes sense. If you still didn't understand it, think of it this way. 20 ohms for 10 meters. So for 6 meters, how much? As simple as that. So that is 12 ohm, guys. Everybody clear till this point? Yes. Similarly, what will be this resistance? RJB. It will be, see, 12 plus something will give you 20. So 20 minus 12, which is nothing but 8 ohm. Okay. Now, the only question is, what will be the EMF of this cell? The EMF of the cell is exactly the voltage between A and G. So, EMF of the cell is exactly the voltage between A and J. That's the balancing point. When this voltage becomes this voltage, no current flows in the secondary circuit. That's the principle of working of a potentiometer. And what is voltage across any resistor when in series? Standard formula. Voltage will be nothing but current into resistance of AJ. And what is the current? The total voltage, which is 5, divided by total resistance. Total resistance is 12 plus 8 plus, what is it? 480. Okay, into AJ. What is AJ? That is 12. Well, this is simple now. 5 divided by, this will be 500 into 12. So this will become 100. So this will become 0.12 volts. That's the answer. Is it there? 0.12 volts? Yes, option D. Correct. No, it is not option A. Be careful. I think you missed the 0 somewhere. Yeah, it is not 1.2. It is 0.12. Yes, the question is lengthy. Solution is easy. You just see why people fail in potentiometer is they by heart some formula. There is no need to by heart formula. Just remember one thing. Potentiometer is all about converting the circuit into simple series and parallel circuit. That's it. You can see this circuit is similar to this circuit. This is equivalent circuit. Yes. Okay. Moving on to the next one. 38th question. Very good, very true, Arvind Kumar. Yep. Yes. Yes, Miss Rockstar. Very good, Sonam Badia. Excellent, Harani, Niveta. Very good. Hello, Natural Fitness, Neelam Singh. Welcome aboard, all the newcomers. Okay. The current sensitivity. A lot of people are going to make a mistake here. I know that. Okay. So the current sensitivity is given. Resistance has been changed by 25 ohm. Then what will be the voltage sensitivity? First of all, what is the meaning of current sensitivity? The meaning of current sensitivity is how much angle it deflects per unit current. And voltage sensitivity, it means how much angle it deflects per unit voltage. Now, we all know V, by the way, I will call it sensitivity of current. This is sensitivity of voltage. Okay. V is IR, but V is theta by SV, look at this, theta by V is sensitivity, so V is theta by SV. Current, well, take SI below, I on the top, so it is theta by SI into R. Theta goes, and I'll be left with SI is equal to V, or I can do this, yeah, R is equal to SI by SV. So resistance is sensitivity of current divided by sensitivity of voltage. Okay. Now what do we do next? Well, see what is given in the question. The current sensitivity increases by 20%. 20% means 1.2. The new sensitivity is 1.2 times. So the new resistance R1 will be, think about it, 1.2 is nothing but 6 by 5 if I'm not wrong. So 6 by 5 times of the previous sensitivity. Okay, I hope this is clear. So this 6 by 5 is coming from this 20% increase. Everybody clear about this? Next point. Over here, the resistance also increases by 25%. So, acha. So the resistance increases by 25%. That means the new resistance will be old resistance, and that is 25% increase. So that is nothing but 5 by 4 times. So 5 by 4 times. And here you have nothing but new sensitivity of the voltage. This is new voltage sensitivity. So let's move this around and see what do we get. SV prime will be, okay, I have SI by R, and here I have 6 by 5, and this will go on this side, so it will become 4 by 5, I believe. And this value, SI by R, check this out, SI by R is nothing but the old sensitivity. This was old sensitivity, and this will become 24 by 25. Acha, interesting. So can't you see it has decreased? How much has it decreased by? 1/25th. It has decreased by 1/25th. Do you see that? It has decreased by 1/25th, guys. So 1/25th is how much percentage? 1/25th. So you can see there is decrease by 1/25th of the original value. So in percentage wise, can multiply by 100. 100 by 25, 4%. So it has decreased by 4%. That is the answer. Yep, Bikramji, that's correct. 4%. 1/25th. Yes, it's 4%. Correcto. Very good. Excellent. So that's how you need to solve this question. Beautiful question which came up on your screen. All right. Moving on to the next one. Engineering physics, whether JEE physics is easy to engineering physics. EGL, that's a wrong step what you are doing. If you are studying engineering physics, that's not correct, because for JEE you don't need to study engineering physics. Okay? JEE physics is easy, plus it is different. JEE is all about solving question papers and hitting the, or getting the right approach in the right time. Okay. 3 infinitely long parallel wires are there, okay, equal distances, wire C experiences net force. Now the net force on wire C when the current on the wire A reversed. So if you reverse this current, this wire, hold your finger down, curl your fingers, the field will be towards you at point C. So the magnetic field due to A will be towards you, and it will be mu naught I, but it is 2I divided by 2R. Okay. Magnetic field due to B, hold your thumb like this, curl your fingers, it goes inside. So it is inside. So it will be mu naught I by R. 2 cancels. Anyways, you see both the magnetic fields are equal. If it is equal, that means it cancels, because one is inside, one is outside. So the final answer is 0. Done, done. Okay, I hope this is clear. Definitely यश क्यों नहीं निकलेगा? वेदांतु से IIT भी निकलेगा, JEE मेंस भी निकलेगा, JEE एडवांस भी निकलेगा, IIT का टॉप ब्रांच भी निकलेगा. This year our top rank is all India rank 35. many students, in fact last year there are more than 500 students who qualified from advanced into IIT. इस साल देखते हैं क्या होता है, but there are more than 3000 students who have got qualified already for JEE Advanced. तो 3000 से ज़्यादा बच्चे हैं, so I'm pretty sure they are going to do really well this year. Okay, moving on to the next question coming up on your screen. अच्छा, now what do you do for this question? Think. Okay, तो ये क्वेश्चन के लिए क्या करें? Let's see. In a hydrogen atom, the electron moves in an orbit of radius इतना 10 revolutions per second. The magnetic moment associated with it. अच्छा, now there is a standard formula which you should know. Magnetic moment by angular momentum is mass by q. Q by this was q by 2m. Yes, this is the standard formula. इसको उधर लेके जाओ. So m will become q divided by 2m into L. Now what is angular momentum? Angular momentum is m r v. You can write it like that, but you can also write it as I omega. Okay. Now what is moment of inertia for a electron? It's a point mass. So it will be nothing but m r square into omega. But omega also you can write it as 2 pi f. This m and this m goes, this 2 and this 2 also goes, therefore m will be equal to, just substitute all these values now, but anyways, q, you have r square, you have pi, you have f, everything else got cancelled. You know the value of charge, 1.6 into 10 to the power minus 19, r 0.5 angstrom, so 5 into 10 to the power minus 11, pi you put it as 3.14, frequency is 10 revolutions per second, so 10 hertz. Substitute, you will get the value of m, as simple as that. Okay, clear guys? As simple as that. तो बस ये value substitute करना, that's it, you will get the answer. Okay, straightforward. You should know the formulas. Angular momentum, you should remember the formulas for moment of inertia, you should remember the formula m by L is q by 2m. If you remember it, that's it. Okay, moving on. Okay, come on, let's do this. There is a air cooled solenoid which length itna, area of cross section itna, number of turns itna, carries current itna. Current is suddenly switched on off for a brief time, ignoring the variations of the magnetic field near the ends of the solenoid. The average back EMF induced across the ends. Okay, so I have this solenoid basically. This is our solenoid. Okay, and what is the average back EMF induced? Okay, so that EMF will be change in the flux magnitude wise upon the time interval. Now it is turned off, remember that. So finally it will be 0. Initially some field will be there, some flux will be there. So it will be BA minus 0. I'm anyways interested in the mod value. So it will be, if you want to write it properly, so final minus initial, so 0 minus BA divided by delta T. So when you take the modulus, that minus sign just goes away and you will be just left with BA divided by delta T. What is the value of B? Magnetic field because of a solenoid is mu naught N I, and this is delta T. But there is a catch over here. This BA will have to be multiplied n times because there are n turns. So you have to multiply it with n, because the flux passing through the solenoid itself will be n times because there are n number of turns. So that's something which you should remember. So into n. Now last few things over here. This is small n, this is capital N. Small n is turns per unit length. Be careful. Capital N is total turns. So this will be mu naught n I n divided by delta T. This small n is turns per unit length. That's it. Now you know what to do. This is mu naught n square I by delta T into L. All the values you know. All the values you know. Like delta T value, I think you know it. What is it? 10 to the power minus 3. Length value, the length of the solenoid 30 centimeters, so 0.3 meters. Current value, do I know it? I think so. It is given 2.5 amperes. N value, that is also given. I think we forgot to multiply by area. That was one thing which we should multiply by. So area, which was pi r square. Yes, we should also multiply by pi r square over here. So I'll just put pi r square over here into pi r square. Okay, now it is fine. Okay, and mu naught value is 4 pi into 10 to the power minus 7. N value is it given? Yes, it is 800 turns. Pi, you know, radius, pi r square. I think pi r square value only they have given already. So pi r square whole value only they have given it as 25 centimeter square. So 25 into 10 to the power minus 4. Yep. So when you do this, then you will get the answer. Yep. Now I think it is fine. Yep. Okay. So everything has to be taken into account. All right. Let's move ahead to the next question. Okay. 16.74 volts. That's what the final answer comes once you solve it. Okay, Gauri Shankar. Okay, Swarlina. A sinusoidal voltage, itna peak value and frequency, the power at resonant condition. All these values are nonsense, not needed, because read this line. Resonant. At resonant frequency, don't have to worry about inductance and capacitance. What happens? The power loss is just equal to I squared R, or you can just say Vrms square by R. So this current, do I know? No, but I can just write it as V square by R. And what is V? Oh, do not write this as 283. That's a common mistake. This is the peak voltage, so convert it. So write it as 283 divided by root 2. So it will be 283 square. Root 2 square is 2. Resistance is 3. That's it. That's what you need to do. Hello, Knowledge Facts. Thank you, Kane Williams Sang Bacha. Welcome aboard. Yeah, that's all you need to do. So the concept over here is ignore this L and C. This is not at all needed, because once it is resonating, the inductor and the capacitor will have the same voltage drop. The total voltage drop will be only across the resistor. Done. Let's move on to the next one. Okay, so do this. You should get it as 13.35 kilowatts. Let's get moving to the next one. Coming up on your screen now. Okay, this one, calculative. These kind of calculative questions will fetch you marks. Guys, how many of you want 90% above? 95% above? Tell me. Yes, Gauri Shankar, that's correct. If you want 95%, 94%, 96%, 98%, you need to do those calculative questions as well. Okay, so let's get moving. So here you have two coils, and if you have another coil which is smaller one on the axis at some distance, the question is the flux due to the bigger one. So what you need to do is figure out how much field comes because of the bigger coil's current. So let's say this is R, let's say this is X, let's say this is small r, and let's say this is B. Now the question is, what's the flux, right? So the flux will be nothing but the magnetic field multiplied by, you know, that pi r square. Now what is this magnetic field going to be? Think about it. The magnetic field due to a coil on its axis, standard formula is mu naught current into r square divided by 2 into r square plus x square whole raised to 3 by 2. That's it. And this will be nothing but pi r square as it is. Now substitute everything, whatever is there in the question. As simple as that. So for example, mu naught, you will put it as 4 pi into 10 to the power minus 7. Current, is it given? Yes, it is 2 amperes. Radius, the bigger circular loop of radius 0.3 centimeters, much bigger loop 20 centimeters. So this is 0.2 meters. Smaller loop 0.3 centimeters. That means 3 into 10 to the power minus 3 meters. And x value I think it is given. Distance between the centers is 15 centimeters. So this is 0.15 meter, and that's it. This r was 0.2 meter. Yes, this was 0.2 meter. Solve this, you will get the answer. Okay, believe me, this is also not that difficult, because you know 20, 15 and 25 are Pythagorean triplets. 20 square plus 15 square, yeah, it is nothing but 625. Root of that is 25. So you can find this out also very easily. It's not that difficult. So solve this and you will get the answer. Okay, I know EGL some car sound, ignore it. Okay, moving on to the next one. Okay, a simple question coming up. If both the number of turns and the core length of an inductor are doubled, keeping other factors constant, then the self-inductance what will happen? This kind of question also came in JEE Mains, let me tell you that. So you should know the value of inductance. By heart that formula. What is it? Mu naught n square pi r square into L. Yes, you have length. Now the number of turns are changed. This small n is turns per unit length. So that's where you need to be careful. So this will become mu naught. You have n square by L square into pi r square into L. LL goes. So this will become mu naught n square pi r square divided by L. Now as per the question, the turns and the length both have been changed. So if n increases 2 times, this will become 4 times in the numerator, and this length has become 2 times in the denominator. 4 by 2 is 2. So this value will obviously increase 2 times. As simple as that. Oh my god. Yeah, so it will become doubled. Well, EGL, looks like you are correct. Yes, knowledge facts, that's the correct answer. Yes, Farlina, that's correct answer. Moving on to the next one. The catch is, lot of people make a mistake here. This is turns per unit length, and turns have increased, not turns per unit length. So you need to do this conversion. Only then you get the correct answer. Moving on to the next one. Now, a lot of assertion, reason questions coming up. Okay. And there is one case study question also. So that's it. Now it's rapid fire mode. Yes, this is for a solenoid knowledge facts, and whenever self-inductance for a coil is mentioned, take it like a solenoid. Assume it is a solenoid. Coil is like a solenoid. Ready for the rapid fire? Come on, show some josh, my warriors. Hi Sabu, welcome aboard. Rapid fire starting now. All are assertion reasons, last few are probably case studies. To increase the range of an ammeter, we must connect suitable high resistance, and reason says when the ammeter range has to be increased, you should give it high resistance. Is this correct? Thank you guys for all the fire. Boom, bam, break. Very good, Arvind Kumar. Come on, let's see. Guys, this is wrong. Yes, A is false and R is also false. Reason, see, when you have an ammeter has very low resistance. Try and recollect. Voltmeter has high resistance, don't get confused. And to increase the range, you make the resistance of the ammeter small so that it becomes even more dynamic and the range also increases. So both are wrong. Let's go to the next one. Okay, come on. Thank you guys for all that fire in the chat box. Here we have the next question. An electron has a high potential energy when it is at a location. Oh, this is tricky. With more negative value of potential and low potential energy when at a location of more positive potential. Okay. So see, when it is at a location associated with more negative value of potential. So energy is an electron. It has negative charge, minus E, into voltage. Now, with more negative value, so when this voltage becomes more negative, so from minus 2 volts to minus 3 volts, minus into minus will become plus. So this value will become more positive. That means it has increased. So it goes to high potential energy. This is correct. What about this? When it goes from low and a low potential energy, when a location associated with more positive potential. So if it goes to more positive potential, well, that means from here to here. If it goes from here to here, then obviously it will become less positive. it will become less positive. That means potential energy will decrease and it goes to low potential energy. Yes, that is also correct. Definitely, that is correct. And reason electrons move from high potential energy to low potential. Okay, electrons always, see, positive charges always go from high potential to low potential energy. But negative charges, remember, negative charges go from low potential to high potential. Keep this in mind. Okay? No problem here. So this is something which you should know. So A is true. Electrons move from high potential to low potential. That is wrong. That is obviously wrong. Electrons go from low potential to high potential. Yes, keep that in mind. Okay, moving on to the next question. Thank you, Sabu Kotoi. All right, thank you so much, bacha. Hello, Divya Peter, welcome. Kaise ho sab log? Moving on. Okay, so given below are two statements labeled, again same thing. A magnetic needle is able to rotate in a vertical plane, orients itself with axis vertical at the poles of the earth. Okay, and at the poles of the earth the horizontal field is 0. That's very true, I think, because when you are at the North Pole or at the South Pole, the magnetic field lines are like this. This is how the magnetic field lines are. The horizontal component is 0. The vertical component is only there. So because of which the needle will become vertical to the Earth's surface. Keep this in mind. Yep. So yes, guys, understand both A and R are true and R is the correct explanation of A. Yep, that is very true, guys. Correcto. Let's get moving to the next one coming up on your screen. Yeah, cool, guys. Can we go ahead? Chalo. Yep. Morning studies any day. Given below again two statements. A proton, electron with same momenta enter magnetic field paths followed by them will be same. Electrons have less mass than the proton. Acha. So what it says is when a charged particle enters a region of magnetic field, they will have same path or no. We all know the radius. The radius is mv by qb. What is this value mv? This is nothing but momentum, and it is clearly mentioned in the question that they have the same momentum and they enter the magnetic field. The path will also be same. Why is the path same? Once the momentum is same, q is same, b is same. That's why they are same. Not because the mass is less. Yes, electron's mass is less, but that's not the reason for it. The charge is same, field is same, momentum is same. That's why the radius is same. So both of them are true, but this is not the correct explanation of that particular statement. Yep, that's why. Ariman, no, I did not have my dinner. I'm going to have my dinner after this session is over. Last 6-7 questions. Okay, shall we go ahead? Yep. Okay, here it comes. Given below again two statements on increasing the current sensitivity of galvanometer by increasing the number of turns may not necessarily increase the voltage sensitivity. And second statement, the resistance of the coil of a galvanometer increases on increasing the number of turns. Well, this is very interesting. What happens when you increase the number of turns? Arvind, please refresh, bacha. Just check this out. Please press refresh. Yep, that should help you. I think just some time back I had given you a relationship. Sensitivity of current is sensitivity of voltage into resistance, or R is SI by SV. So if you increase the number of turns, when you increase the number of turns, resistance will increase and the current sensitivity will also the current sensitivity will also increase. So maybe this remains constant, maybe it does not change because R has increased, current sensitivity increased, but SV did not change. So guys, the correct answer is both A and R are true, and R is the correct explanation of A. Yep, it is A, correcto. So resistance increases, current sensitivity increases, voltage sensitivity remains the same as it is. Okay, Moving on to the next question, 50th question coming up on your screen now. Yep. So based on probably some subjective types, and what you have is a charge which is hanging, standard question. It makes an angle theta, then the sign and the magnitude of the charge. Very straightforward. This is tension, this is mg, and because it is going there must be an electric force QE. Now resolve this tension into two components. This is theta. Look at that. Tensions sine theta in the x direction. Tensions sine theta balancing QE. In the y direction, tensions cos theta is balancing mg. Divide both of them, sine by cos, tan, tt gone. So this will become QE by mg. What is asked? Q. So Q will be mg, nothing but tan theta divided by E. So that's the answer, guys. Just check this out. So mg by E and tan theta is there, and the charge will be positive. Yep, the charge is positive because it got deflected in the direction of the field. If the charge was negative, then it will get pulled on this side. So it is positive, and whatever value we found out was also correct. Moving on to the next one. Yep. A free electron and a free proton are placed. Situation based question. Let's see if we can do it. Both are placed very close to the positive side of a charged capacitor. Which of the following statement true? No, this kind of questions will not come in JEE Advanced. These kind of questions can come in JEE Mains examination. Okay, come on my warriors, think about it. Let's see if we can get it. So the force, where is the force more? Well, there is some field from here to here. Obviously there is some electric field, and the force on the positive charge will be this way, and it will be charged into field. On negative one, it will be charged again into field. Force on the proton is greater? No, in fact it is equal. Potential energy is more or less? Well, think about it. Potential energy, guys. Potential energy is charge into potential. Both the points are at the same potential. Energy will be different because energy is charge multiplied by potential, and the charge for a proton is positive and for an electron is negative, and positive numbers are always more than the negative number. So hence the potential energy of proton is greater than that of the electron. Is that making sense? Positive wise it is more, sign wise, magnitude wise they are same, but yep, they are the positive value will be more than the negative value. I hope this is clear. Yep. Yes. Why one is incorrect? The force is not more. Proton and electron have the same charge, same field is there, so force is charge into field. I just showed you. This force is this way, that force is that way. Directions are opposite, but the magnitude is same. Hence they are same. So it is not greater. I hope that makes sense, knowledge facts. Okay. Now read the situation. This is a case study. Venkata, there are 55 questions. So last 3 or 4 questions coming up on your screen now. Read this. Take a screenshot if you want. Okay, take a screenshot. I will show you the questions based on this passage or this case study. This is how your case studies will look like. Yep. Shall we go ahead? Okay, my audience, can we go for the questions based on this? Alright, let's do this. First question. Which of the following statement is true? Energy created when a transformer steps up the voltage. Transformer is designed to convert AC into DC. Step up transformer increases the power. Step down transformer decreases the AC voltage. Guys, this is very obvious. Please do that. Yes, but same magnitude. Correct, Shalini. But whenever you compare potential energy, always compare with sign. Whenever you compare force, do not worry about the sign. Okay, remember that. Okay. Yes, the correct answer is D, step down. This is so easy. Please tell me. Yeah, this is so easy. Step down decreases the voltage. A transformer never converts AC to DC, it converts AC into AC only. Remember that. And energy is usually constant. There are some negligible losses depending on how it is constructed. Next, secondary coil has more turns than the primary coil. Then, what will happen? The voltage is stepped up, voltage is stepped down, current is stepped up, current is stepped down. Think about it. If the secondary coil has greater number of turns than the primary, then what happens? Think about it. Yes, Venkata, CBSE released only one sample paper. Yep, that is enough. I mean, solve these questions, you get an idea. Guys, secondary coil has more turns, so what will happen? The voltage will go up, right? Yes, knowledge facts. Secondary voltage is more than the primary voltage. As simple as that. Yep, secondary voltage, and this is called as a step up transformer. Very good. Let's get going. Okay. In fact, the current in a step up transformer reduces. This is also wrong. The current is not stepped up. The current goes down in a step up transformer. Voltage increases, current decreases. Keep this in mind. Okay. Next, we need to step up the voltage for power transmission. So that what? Very basic use of transformer. You should know this. You need to step up the voltage of a transformer. Why do you step up the voltage of a transformer? What is the reason for that? This is very straightforward. You should know it. Okay. Yes, knowledge facts. The force will be attractive, one will be repulsive. But the question was not to compare attraction and repulsion. The question was to compare the magnitude of the force. Okay. So when they ask you to compare force, just compare the magnitudes. It's not like attraction is more than repulsion or repulsion is more than attraction magnitude wise. Magnitude is the modulus. Okay. Yes, come on. Let's get moving. The answer is very simple. The current is reduced. Consequently, the I squared R losses in the transmission. Remember, at the substation where the electricity is generated, the voltage is increased, the current decreases. So the current's square R, the I square loss in the cable, the wire which comes from your generating plant to your house, that wire will have negligible losses. That's the reason for that. Okay. Last question. This is numerical. This is very straightforward. Okay. You should be able to do it. Power transmission line feeds input power at 2300 volts to a step down transformer with its primary windings having this many turns. The number of turns in the secondary in order to get output power at 230 volts. Okay, so Vs by Vp is Ns by Np. Just do that and you'll get the answer. What is Vs? Input power is given and it is secondary. Okay, 230. So this is 230. What is primary? This is 2300. Okay, step down transformer. Primary windings are 4000. Okay, so this is 4000. The question is, how much is this? This is very obvious. 10 times less. That's it. This should be 400. Yeah, 400 is the answer. Please tell me you got 400. Very good. Option C. Correcto. Correct. Yes, that's the answer. So that's the paper discussion, guys. And by the way, this is not the only paper. There are more papers which Vedantu will discuss in the CBSE batch. There is a CBSE batch which is a part of the Vedantu Pro subscription. Once you get enrolled in the Pro subscription, all the classes, live classes are going to be conducted. CBSE assignments, CBSE mock tests, CBSE preparation along with JEE mains preparation. Everything is done and you will get free access to my courses as well. So not just this, guys, also you'll get tests, assignments like I told you, with teachers specializing in CBSE, and the teaching happens in English, but if you want, there is a Hindi batch as well. All of this comes with VIP, which is Vedantu Improvement Promise. That means if you do well, that's very good, and if you by chance don't do well, then you can take back your fees, no questions asked. All of this at very affordable rates. This is 36,000 till your JEE Advanced examination. This is the light version. In the classic version, you additionally get doubt solving. And in the plus version, what will you get? You will get a personal mentorship. So personal mentor will help you make your schedules, motivate you, give strategy sessions and other things which are required by some students. Most of the students go with the classic version because they want the doubt solving ability as well. So you can try it out for 1 month. There is a link in the description box which says 12th Standard Pro subscription. Check out that link. Check it out right now and try to use it for at least 1 month. That's what I would say. No harm. And if you don't like it, it's okay. Yep. So these kind of questions will also come in JA exam. Very good. Thank you guys very much. Bye bye Shalini. Bye bye Vishu. Bye bye Knowledge Facts. Harini. Take care. Bye bye Arvind. Yep. Nice to see you Arvind in the full stream. Bye bye Gauri Shankar. Have a great time. See you guys on Monday. Have a happy weekend. This was Shreyas here. Hasta la vista. Bye bye.